All right, let's continue on with some more examples in 8.4. Let's say we want to integrate x squared minus x plus 9 over the binomial x squared plus 9 squared. Now this is proper because technically this x squared squared would be x to the fourth. So the top power is smaller than the bottom power. We don't have to worry about any division. All right, so we can factor the bottom, which technically it's already factored for us. We just have this x squared plus 9. We can't factor it any further, and there's two of them. So start with your x squared plus 9 squared. Put up two terms up above. Remember we said if it's power of 2, you have to have two terms, an x to the first, and a constant. Subtract 1 from the power. Now there's x squared plus 9. Again, we'll put in a capital CX plus D. All right, so this is my least common denominator. And again, if I multiply it to everything, I'll get x squared minus x plus 9 equals ax plus b. This cancels. And then I'll have cx plus d multiplied to another binomial x squared plus 9 because I'll only be able to cancel out 1 when I multiply by x squared plus 9 squared. So here, what I would do is we're going to FOIL this out. I would FOIL this out. Again, you start working with quadratic factors. It's impossible to make this into a 0. All right? So I'll multiply that through. So ax plus b equals cx times x squared, cx cubed. Cx times 9, 9cx. D times x squared plus dx squared, d times 9, 9d. I just opted to put that in descending order that I've multiplied out. All right, so this one is collect like terms. So we're going to look for x cubes. I only have 1. There's no x cubed over here. So that's a 0. So 0 is equal to c. So what does that tell us is that there will be no x term on top of the second fraction. Collect your x squared terms. We have a 1 in front of our x squared. So 1 is going to be equal to, we only have dx squared. So now we know d is equal to 1. So there's a 1 on the top of that fraction. Collect your x to the first terms. That's a negative 1 right there. So that's ax plus the 9cx. Oh, but wait a minute. Negative 1 equals a plus 9c, but we already know that c is equal to 0, so this zeroes out. So a is equal to negative 1, so that's a negative 1x right here. And then for your constant, the 9 is equal to the b plus the 9d. But again, we know the value of d. So let's put a 1 here. That's 9 times 1 is 9. 9 plus b equals 9. That indicates that if you subtract the 9 over, b is equal to 0. All right, so I have my partial fraction decomposition. Negative 1 goes in for a. B is the 0, so we don't need it. So negative 1x over x squared plus 9 squared plus, now we take our c, which was a 0, and our d was a 1. 1 over the x squared plus 9 dx. So here we can do a u sub. All right, x squared plus 9 can be your u. The derivative is 2x dx. Well, we got an x term, that's good. All we have to do is divide over the 2, and that will give me 1/2, and multiply to the negative 1 out front, negative 1/2. And I have 1 over u squared du, which I can change that to u to the negative 2 power. We can integrate that, u to the negative 1 divided by negative 1, which, well, this negative and the negative on the 1/2, that will cancel each other out to be positive. Put the u back into the denominator and put your x squared plus 9 back in. So that's the first integral. This integral, well, that's in that 1 over x squared plus a squared, which is going to be 1 over a multiplied by the inverse of tangent of x over a. So here a is going to be 3. So that will be 1/3 inverse tangent of x over 3. And then we put in our plus c. All right. Now, sometimes there is a shortcut to doing all this work. It doesn't happen too often, but when you read the problem the first time, you may have noticed something similar top and bottom. As I read this, I noticed there's an x squared, there's an x squared, there's a plus 9, there's a plus 9. So what I'm going to do is, because there's, if you will, one giant factor in the denominator, I'm going to rewrite this as x squared plus 9, the first term and the last term, over the x squared plus 9 squared binomial. Then take the minus x and write it over its own denominator of x squared plus 9 squared. And so here, x squared plus 9 in the first numerator can cancel with one of the x squared plus 9 binomials on the bottom. So that's going to be a 1 on the top. And lo and behold, there's my two fractions. So again, once in a while you will see this shortcut. It's neat and handy if you see it. Then I can go ahead and integrate them both individually. All right. So next example, see if you see a shortcut. I have x cubed for my leading term. X squared times x squared would be x to the 4th. It's a proper fraction. The denominators are already factored. I can't factor x squared plus 1. That's a quadratic factor. X squared plus 2, can't factor it. But I'm noticing that things kind of look the same top and bottom. See if you can see the shortcut. Here's an x squared, here's a plus 2. Let's take these two terms and write it over this denominator. Then the other two terms, x cubed and the plus x, write it as its own fraction. Now, why did I want the x squared plus 2 by itself? It matches the bottom binomial. They cancel. 1 over x squared plus 1. Over here, I'm hoping to get the same thing. The top, there's a GCF of an x. So let's write that as x times x squared plus 1. Wait a minute. X squared plus 1 on the bottom with what's on the top. Cancel those out. And so now I have the integral of 1 over x squared plus 1 dx plus the integral of x over x squared plus 2 dx. And there's my shortcut. So again, this one right here, that's going to be my inverse tangent rule. X squared plus 1. 1's a perfect square, so that's 1. So 1 over 1 is 1. So this will just be the inverse tangent of x over 1, which is x. That's this integral. Here we're going to probably do a u sub. Let x squared plus 2 be equal to u. Take the derivative, which is 2x. Divide over the 2. There's my x dx. So we'll have plus 1/2 times the integral of 1 over u, which becomes the natural log of the absolute value of u. And then put your x squared plus 2 back in for the u. And put on your plus c, and we have it done. Example 5. Oh, wait a minute. This is not proper. Top power 5, bottom power 3. We have to divide. So we have to do long division. All right. Now, some people tell me, I agree with it at times, especially when you're first starting out, but you should have seen this before. You should put in every single term here. X to the 5th plus 0x to the 4th minus x cubed plus 0x squared plus 0x minus 1. because you want to keep all those like terms lined up when you multiply. But in this case, notice that 5 to 3 is a difference of 2. 3 to 1 is a difference of 2. I don't need to put in my zeros. So when you do line division, you can only divide leading terms. 2x to the 5th divided by x cubed is 2x squared. So if you did put the zeros in here, you'd want to line that up over your 0x squared term. Multiply this to the front. You get 2x to the 5th minus 8x cubed. And now you subtract both columns. You should cancel the first leading term every time. Minus a negative plus plus, that's going to be 7x cubed. Bring down the minus 1. Divide new leading terms. 7x cubed divided by x cubed is a plus 7. Multiply that out, we get 7x cubed. 7 times the minus 4x is minus 28x. That's why I kind of moved the minus 1 over. These are not going to be like terms. So I still put in my two minuses. There would be a 0x here, if you will. 7x cubes cancel. 0 minus negative. Okay, plus plus. That's 28x minus 1. And we put that over our denominator. So it's 2x plus 7 plus 20x minus 1. And then I'm going to factor this denominator. I can take out an x. Gives me x squared minus 4. Difference of perfect squares, x plus 2x minus 2. So this fraction now changes to this expression. Now, why is that nice? You can now write 3 separate integrals. Factor out the 2, factor out the 7. We can integrate 1 dx, or you can leave the 7 there. We'll integrates to 7x. And then we have this partial fraction that we're going to have to solve for. So focus right here. All right, 3 linear factors. This fraction is equal to a over x, capital B over x plus 2, capital C over the x minus 2. So this is my least common denominator. Multiplying this to everything cancels this denominator. Here the x's cancel, leaving me x plus 4x minus 2, which is x squared minus 4. Multiply this denominator to x plus 2, leaves me x and x minus 2 to multiply to the b. Multiplying this factor denominator to this fraction cancels the x minus 2's. I'm left with cx times x plus 2. So here we're going to distribute the a. Ax squared minus 4a, distribute the bx, bx squared minus 2bx, distribute the cx, cx squared plus 2cx. All right, my x squared term, slow down, mouse. There is no x squared, so that's going to be a 0, but I have an ax squared, a bx squared, and a cx squared, so a plus b plus c equals 0. My x to the first term is 28. So it's going to equal 28. So I have, here, negative 2bx, so negative 2b, plus 2cx, plus 2c. So a 0 goes in for your a right there. And then your constant negative 1, that's your negative 4a, and that's the only constant one we have. So you can solve this, egads. All right, here's my downside. I cannot do any back substitution because there's no a here. I can solve this for a, plug it in here, subtract it over, and solve a 2x2 system, maybe substitution or elimination method, but in all honesty, it's quicker just to put it in the calculator. 1, 1, 1, 0, 0, negative 2, 2, 28, negative 4, 0, 0, negative 1. RREF, there's your answer. A is equal to 1/4. B is equal to negative 57 over 8. C is equal to 55 over 8. So bring down those two first integrals, and then we're going to integrate 1/4 over x dx. Then we're going to integrate a negative integral for the negative 57, 57 over 8 over x plus 2 dx, plus our integral 55 over 8 over x minus 2 dx. So, next slide, just to get a little bit more room to do all this work. This becomes 2x cubed over 3. We get a plus 7x. Here, we're going to just factor the 1/4 out. So that's 1/4 integrate 1 over x. That's the natural log of the absolute value of x. Move out the 57 over 8. So minus 57 over 8 times the natural log of the absolute value of x plus 2. Move out the 55 over 8, so plus 55 over 8 times the natural log of the absolute value of x minus 2. And then tag on your plus c. And we are done with section 8.4.